Okay, students, good morning. This is Shivash Patel and welcome to Math Chef YouTube channel, right? So today yesterday we discussed real numbers and polynomials, and there's nothing but continuation of the polynomials also. A new chapter also we can call pair of linear equations in two variables. Pair of linear equations in two variables. Okay. So linear equation, before what something the polynomials is algebraic expression of two variables. Polynomials. Okay. In last classes we have studied what the polynomial is algebraic expression. Algebraic expression of variables in terms of x and y, a and b, p and q, s and t, etc. Right? Based on this we have two kinds. Based on terms and based on the degree of the polynomial. Degree. Okay, we have terms. Here you have monomials. We have binomials. Two terms. Binomials. Trinomials. Three terms. Trinomials. Terms means this one. 2x plus y plus z. Okay. This is one term, two term, three term. Okay. If it is x, this is 2x. This is 2x plus y. This is 2x plus 3 plus y. Three terms, trinomials. Right? Based on degree. Okay. So you can also for four terms polynomials. That's why we call polynomials. In terms of degree, okay, in this variable, okay, the general form is x plus b, okay, x square plus bx plus c squared. So this is the highest degree of the variable. With respect to highest degree in the variation in the equation, we defined different kinds of the equations. If the degree is equal to 0, okay, if degree is equal to 0, we call this constant equation or constant equation. Like that, y is equal to x to the power 0. You can write plus 1 is equal to 1. What will be? The power of the x is 0. Means anything power to the 0 is 1. So the formula a to the power 0 is equal to 1 now. Indices, right? If d is equal to 1, degree is equal to 1, y becomes x plus 1. So maybe 2x is okay. So general form is ax plus 1. Ax plus b, not 1, b. Here d is equal to 1. This is called linear equation. Linear equation. So if degree is 2 called quadratic, degree is 3 called cubic, if degree is 4 is called by quadratic equation. Right? Similarly, so this concept, pair of linear equations in two variables, is completely concerned to this equation. Okay, there are two variables, means it should be a binomial or trinomial. Equation should be binomial or trinomial, and degree should be 1 out of the two variables. Okay, so what is the linear equation is? What the linear equation means? Linear equation means the degree of the variable is 1. Degree of the variable in the equation is always 1. Always 1. Unity also. Always. Like that, p of x is equal to 2x plus 1. P of x is equal to 2x plus y plus 1. Not p of x is equal to, okay. This is the equation, something else. You should not write, okay, this one separate term, because now there are two variables. P of y is equal to 2y plus 1. P of z is equal to 2z plus 1. Okay, whatever it may be, depends on the variable, depends on the this one. This is called linear equation. Okay, similarly, see, linear equation, I wrote this one is different. Okay, what we're writing is pair of linear equations. Pair of linear equation. Have taken two variables. See, if you are writing the equation in only x is called one variable. Equation in one variable, that is x. Okay. Equation in two variables. That is, here is x, here is x and y. So we can call 2x plus y plus z also we can call equation in three variables, that is x, y, z. This now how we can write p of x, y is equal to, not only for exam purpose, only for null purpose, this equation writing as p of x, y in terms of 2x plus y plus 1 is equal to something, right? Here we can writing as p of x, y, z is equal to, if it is only one variable, we are taking the 2x plus 1. If it is only one variable, 2y plus 1. One variable, 2z plus whatever it may be. General form is ax plus b, right? This is general form is ax plus by plus c, right? Two variables, three variables, ax plus by plus cz plus d is equal to something. Concerned, three variables we are writing as p of x, y, z is equal to ax plus by plus cz plus d is equal to 0, and a, b, c, d is the any real numbers. Here also for p of x, y, this one is ax plus by plus c is equal to 0. What our concern is a pair of linear equations in two variables. This only we are calling. Okay? Means pair we are taking. Not only we are considering this one as, okay, this one. So I am writing again one again. xy is equal to a1x plus b1y plus c1. Then similarly another equation we are taking a2x plus b2y plus c2. This is the name headings. Okay, according to heading, pair means two of linear x and y of x to the power 1, y to the power 1 linear equations in two variables x and y. This is the general form of pair of linear equations in two variables. Okay. This is the LPE, linear equations, pair of linear equations in two variables. You can write pair of linear equations, PLE, pair of linear equations in this form. Okay, it may be whatever it may be, 2x plus 3y, something else. Okay, so we will take the practical example. Okay, practical example. Here you have graphical method of elimination. I have to mention the graphical method also. That is, consider. Just imagine you are and your friends went to their hotel. They have a tiffin or breakfast. So there are only available, many items are available. Depends on the, see, items are like that x and y, z. X, y, z. If there are two items are available, only x and okay. Right? If it idli is available, idli in your hotel, you call it x. If it puri is available, we call it is y. If something else, rice is available, something else we call z. Depends on the whatever it may be items. Okay. With concern to this one, x and y. So you and your friend, two people went. Pair means two people. Huh? We need two people, two students. Okay. You and your friend went to the hotel, and we don't know the cost. X rupees, y rupees. One plate, the idli of the cost is 20, 30, whatever will be, but depends on the hotel. X rupees and y rupees. Puri is y rupees, x is idli is x rupees, puri is y rupees. Then you ate 2 plates of idli plus and 3 plates of puri. Then you are billed at ₹100 rupees. So you ate 2 plates of idlis and 3 plates of puris, and your billed total value is, total amount is, have to pay for 100 rupees. Right? Randomly you are given. So you have got the bill. For similarly, your friend, okay, your friend will eat 3 plates of idli and 2 plates of puri, and again he will getting 150 rupees. Right? You ate 2x plus 3y, 2 idlis, 2 plates of idlis and 3 plates of puris, and you are billed at 100 rupees. So here your friend ate 3 plates of idlis and 2 plates of puris, and he got the bill of around 150 rupees. Our motto is here, find the what is the same hotel, same price. Same hotel, same price, but different quantities you ate. Right? So our motto is find the, so then what would be the value of price of the idli and price of the which one? Puri. So this is the practical example of the linear equation. So pair of linear equation. Not only for hotel, you can purchase the bats and balls, different kinds of bats, different kinds of balls with respect to money, and you can running race, okay, and your capacity of work, something else, okay, the car race, boat race, whatever may be, you can take the numerous practical real life examples, right? So this is the main concept here, okay. What is the pair of linear equation is equation in the form of x and y, two variables with the degrees only one. X and y, degree is 1, and with same equations, different copy, okay. There's only 2 equations at a time. That's called pair of linear equations in 2 variables. Pair of linear equations means degree 1, pair means 2 variables means x and y, is called pair of linear equations in 2 variables. This is the practical example, but this is the theory. Then have to see the how the geometrical representation or the graphical representation, how it shows. Is the line or curve or point or triangle or square or something like that maybe. Have to represent the geographical meaning, geometrical meaning or graphical meaning. So let's check, okay. This concern the with respect to this one. Again the one condition given, okay, and this with respect to this one, a1 square plus b1 square not equal to 0. Similarly, a2 square plus b2 square not equal to 0. This condition, okay. If something is there, means a1 and a2 should not be equal to 0, right? If I am getting 0 here, something, because this is the value. If getting 0 here, you are not possible to frame the equation. So square means it may be real numbers, root 2 something else, minus something else, that should not be happen here, okay. Instead of writing even not equal to 0, so we are taking this sum, okay. In come to the next lessons, you came to know why it is y1 square plus b1 square or a2 square plus b1 square not equal to 0, okay. If something happens, then this becomes constant again. You get the constant function, right? Let be. So once again, the linear equation is based on degree. We have the linear constant function, linear function, a linear equation, quadratic equation, biquadratic equation, and cubic equation and biquadratic equation. Based on terms, we have nomial, monomial, binomial, trinomial, and polynomials. Based on degree, we have constant equation, linear equation, quadratic equation, and biquadratic equation. So this chapter is concerned to only for linear equations. This is also called simultaneous equations. Pair of linear equations is called simultaneous equations. Okay, at the introduction, let's see the graphical representation. Guys, first I will give you one equation, and one more thing is, and any value of x and y here, okay, any value of x and y here is a point on the line, okay, point on the line. So it's almost line ax plus b plus c is equal to 0, whatever it may be, okay. How means just if you take the 2x plus 3y this here, for x value have got x equal to 0 and the y equal to, we will get 100 minus 2x by 3. So okay, so if it's 0, we are getting 100 by 3, and if it is equal to 2 or 6, if equal to 3, we are getting 3, 6 na 9 2 means 3 2. So these point 0 and okay sir, these point 0 and 100 by 3 and 3 and 32 are the point on the line. Every solution you can call solution, so we can call solution set. These are the every point on the points on the line. So by this we can draw the line. Okay, let's see the solution is what? Solution is the pair of line where intersects each other. That is solution set. Okay, so what is the any equation, the value of x and value of y with respect to x is a point on the line, this line, whatever it may be, because now you can take the x is independent variable. With respect to x, you are getting the y values. So every xy indicates the point on this line. Okay, let's see the one graphical representation. Okay, one equation. We have to show this equation is a straight line. Take this simple equation. So x, okay, let's 2x plus 3y is equal to 6. Only for simplification I have taken. So simplify it. Means take the value 3y is equal to 6 minus 2x and y is equal to 6 minus 2x is equal to 3. So x is the independent variable and y is the dependent variable. Take the value of x equal to 0, we will get y equal to 2, x equal to 1. Take the integral multiples. Integral multiples means 2, 3, 4, 1, 2, 3, 4, 5 like. Okay. What will be divided by the 0? X equal to 1, 4 not possible, 2, 4 not possible, and this 2, 0, 1, let's take the, what it may be, 1, we will get 6 minus 2, 4 by 3, and okay, just I am taking here, can I take this is equal to 1, okay, now just to show the line independent, okay, you should not take the complicated here, 1, this is 1, this is 1, again we are getting things now. Let's take the book's example. 2x plus 3y. Maybe. Whatever it may be. Let's take the data only. 6, 6, 6. Right? For h equal to 2, 4 minus 6 minus 2, 4, 2 by 3. 2 by 3, again just make here 2, 3 point means 4 means 1.3, 3 means 0.6, right? 3, 6, 0, yes, 4 means 6 minus 8, 2, 6 minus 8, 2 by 3, minus 2 by 3 means minus 2 by 3, this is minus 0.6. Okay, let's plot the graph here. Okay, just take this is the y axis, this is the x axis, positive x, negative x, this is 0, positive y, negative y, y dash, x dash, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 4, 5, 6, 7, 8, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, 1, 2, 3, 4, 5, 6, 7, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Just put the value x and y here. With respect to x, okay, x equal to 0, y equal to 0 to x equal to 0. This is the point 0 and 2. Okay, if writing this one as na x and y, you should consider x and y. This is like it. For 1 we have 1.3. For 1 we have 1.3 here. This is the 1.3. 1 is equal to we have 1.3. For 2 we have 0.6. For 2 we have 0.6 here. 0.2, 0.6. For 3 we have 0 exactly here. For 4 we have minus 0.6. This is 0.6 now. For 4 we have 4. This is 0 and 3. 3 and 0. 3 and 0. This is 4 and 0.6 minus 0.6. Right? This is the sheet now. This becomes a complete straight line. This is 4 to 0.6 minus, right? This line, okay, the straight line. This is the line is equal to 2x plus 3y is equal to 6. Right? So I told you already, in the form of ax plus bx, ax plus by plus cy, okay. The form, this is the general form, okay, whatever it may be, ax plus by plus c is equal to 0. Every x and y represents the points on the equation, points on the line. Any straight line, okay. Straight line is completely like that, okay. Ax plus by will get, definitely will get only this form, whatever it may be. It never bends because the degree is 1. So you should get only one zero of the polynomial, means it cut the x-axis at only 1.5, 1 a point at the x-axis. So this is the general equation, okay. For pair of linear equation means the, how to show the another equation here only. Another equation means to check. Let's check 3y plus 2x is equal to 6, right? 3y plus 2x is equal to 6 now. This is again how you will write y is equal to, I have to write 6 minus 2x divided by 3. Okay, this is will be same again. This should be 3x plus 2y is equal to 6. So here y is equal to 6 minus 3x by 2. Put the value again here, and y x equal to 0 will get y equal to 3 by 2. This is 1.5, and this one x equal to 1, 6. Okay, this is the 6 3 na. This is 3. X equal to 0 we will get 3. X equal to 1 we will get 3 by 2. 3 by 2. This is 1.5. X equal to 2 we are getting 0. And x equal to 3, 9, minus 3 by 2, minus 3 by 2 is minus 1.5. Just plot this one. Okay, just plot that one. X equal to 0, y equal to 3. This is the point. 0 and 3. X equal to 0, x equal to 1, y equal to 1.5. Y equal to 1.5. Here something else. This is x equal to 1, y equal to 1.5, and x equal to 2 we are getting 0. Right? Something else here. Right? This is x equal to 2, y equal to 0, and x equal to 3, 1.5. X equal to 3 we are getting 1.5 is here now. This is 3 into minus 1.5. See them. Connect all these lines. Okay. These lines. Yes. Okay. This is the other condition. This line. Okay. This line is 3x plus 2y is equal to 6. Okay. This point is very important. No? This point. Something else you are getting. Okay. Where you are getting 0, x equal to 3 and y equal to same way you have to getting y. Na? Yes. At 2 and 3. So here at x equal to 1, 1.3, at x equal to 1, 1.5. Yes, x equal to 1 we are getting 1.3 and x equal to 1 we are getting 1.5. Nearest value. Okay, this is this set. This is called general solution of the two equation. Okay, this is called general solution. By substituting also value, we have three methods: elimination, substitution, and cross multiplication. And cross multiplication is for not your syllabus, and elimination, substitution is for your syllabus. Then you can, for that method, you can show the line cuts exactly this point. Line means the common point between the two lines. This is called 1 and 1.5. This is the common point for the two lines. X, Y is 1 to the 1.5. Okay, 1.3 nearest value, 1.5 is the nearest value. You can take the 1.4 also in between value. Exactly 1.4 is the common value. So later we can see the equation, but only for the graphical representation. Okay, this line is 3x plus 2y is equal to 6, and this line is 2x plus 3y is equal to 6. Both are which were straight lines. Okay, by property of these lines. Okay, so let's see some equations. Okay, yes, they given also questions here. Some exercise 3.1. 3 questions are word questions, word problems. Same. Okay, same. They went to the purchase the bat and balls with some respect amount. Okay, they have to represent this something else. Okay, so first this is the algebraic form. Okay, this is called algebraic expression, whatever it may be. Algebraic expression of the word problem. Okay, this is graphical expression, graphical representation. Graphical representation of the problem, linear equations. Okay, you can draw 1 also, you can draw 2 also, you can draw 3 for infinite. Many equations you can draw on the same, this one, same graph. Okay, let's see the word problem here. One word problem. Let's see. Okay, yeah. One question from the exercise 3.1. Okay, first one is okay, second one taking. First is also easy, second one also easy. The coach of a cricket team buys 3 bats and 6 balls. Okay, sir. 3 bats. He is purchasing 3 bats. 3 bats. We don't know the price. And 6 balls for rupees 3,900 plus 6 balls. This is bats for rupees 3,900. Later, she buys another bat and 3 more balls. Another bat. Again, he purchased 1 bat plus 3 balls. Okay. Of the same kind of for rupees 1300. Okay. Represent this situation algebraically and geometrically. Okay. This is almost algebraically done. First second. Let's take the again. Let's x be the value of price, value of bat, and y be the value of or price of ball, 1 ball. Right? Consider algebraically, how writing algebraically, algebraic expression, algebraically expression. What the first question is? He is purchasing 3 bats plus 6 balls, right? Total amount is 39,000, 3,900. Okay. Another same kind of bat, another bat is x plus 3y, 3 balls, total amount is 1,300 here. This is the algebraic representation, right? 3 balls, 3 bats, 6 balls cost 1,300, okay, 3,900, 3,900. 1 ball, 3 balls cost 1,300. This is algebraic representation. Okay. Let's see the which one? Graphical method. Graphical method, for I have to find the y. 6y is equal to 3,900. So y is equal to minus 3x. 3,900 minus 3x. So y is equal to 3,900 minus 3x by 6. This is equal to 1,300 minus x by 2. Yes. 3 is common on all elements. So, for here, 3y is equal to 1,300 minus x. So, y is equal to 1,300 minus x by 3. Have to plot the graph with respect to this one, right? Okay, just take the graph, x-axis and y-axis. This is positive x, this is negative x, this is 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Positive 1, 2, 3, 4, 5, 6. Negative y, y dash, positive y, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 1. And see, it is not possible, it could not possible to plot the 1, 2, 3 because thousands, no, hundred and thousands. Just make the scale 1 unit is equal to 1 unit is equal to 100. Whatever it may be. Rupees. 1 rupee is equal to 100 rupees. 1 kilometer is equal to 100 kilometers. 1 kilo is equal to 100 kilo. 1 watt is equal to 100 watt. 1 watt is equal to 100 watt. Whatever it may be. Depends on it. If it is in thousands, take 1 is equal to thousands. If it is lakhs, take 1 is equal to 10 lakh. If it is 10, take 1 is equal to 10. Nothing but here, if 1 represents 100, 2 represents 200, 300, 400, 500. Similarly, 100, 200, 300, 400, minus 100, 200. Okay. That is the scaling here. Scale means 1 is equal to 100. I am taking this for. Right? Let's put the values for respect to this one. So x and y. Okay. If x equal to 1300 na. If x equal to 100, we are getting 600. X equal to 100, y is equal to 600. 1300 minus 100 is 1200. If x equal to 200, not 200, take 300. 300, y equal to 500 we are getting, and x equal to, because at multiple of 6, x equal to 500 we are getting 800. 500 means 800 by 2, 400. X equal to 500 we are getting 400, and whatever may be, x equal to 700, even 300 na, x equal to 700 we are getting 300. Yes. Again, for this one, this you can call as y1, this is y2 I am calling. For y2, this is y1, this is y2. Okay, same, put the value. H equal to this is 3 na, this is 3. You got one simple answers only. 100, yes, possible. 500, something else na, just put the values. X equal to 100, you are getting 200, 400. X equal to 300, right? X equal to 300, you are getting 1000. 1000 means 3.3, 330. Okay, 303 also you can get. X equal to 500, 800. Okay, this is not good. So not getting the integral value, na? So we will not plot here. We will take the another one. This is okay. For x is equal to here, y corresponding to these values, take x equal to 100, x equal to 100, you are getting y is equal to 400. 1200 by 3 is equal to 400. And then x equal to 400, x equal to 400, you are getting 300, 900, no? 1300 minus 4 is 900, so divided by 3 is 900. And x equal to 7, we are getting 6, x equal to 700. Okay, 13 minus 7 is 4, 6 by 3 is 200. Just plot it, okay? Just plot it. For this equation, for which this equation is, which one? 3x plus 6y is equal to 3900. 100 is equal to 600. For 100, we are getting 600. Right? This equation. For 300, we are getting 500. Right? Still not is getting, okay? Then for 400, or for 500, we are getting 400. Right? For 700, we are getting 300. Something is there. Okay? Let's continue here. For 700, this is 6, na? This is 7. This is 7. 300 you are getting. Okay? Just continue it. Draw it, join the all points. Okay? Then for this equation, x equal to 100, we are getting, so this is line, this line is which one? 3x plus 2y, 6y is equal to 3900. This line. For this, we have x equal to 400, 100 is equal to 400. This is x equal to 400, we are getting 300. This is, and x equal to 700, we are getting 200. This is 7 is 200. This is, okay. Just draw the line. This, okay. Exactly this, okay. Exactly at 1300. Okay, you can check here also. Exactly at 1300, that's the point here. X equal to 1300, then y equal to 0. This here 0 is equal to, we get 1300, you get 0. Look now, 1300, 13 to 3, 39, this becomes 0. 1300 minus 1300, 0. This is the beauty of this equation. This is equation is which one? X plus 3y is equal to 1300. So this point is here. X equal to 6. This is the 7, 8, 9, 10. This is 11. Okay, this is 13. 1300. No? I taken here only units 8, 9, 10 up to 13. Exactly this value. We are getting value y equal to 0 for both equation. This is the general solution. X equal to means the corresponding value of same equation of the x. We are getting the value y equal to 0. One solution, right? With respect to exercise 3.1, second question number. Okay, but only our motto is to find that is the algebraic method, this is the graphical method. Okay, see in your exam you should take the 1 unit is equal to 200 units. Okay, if take the 1 unit is equal to 200 units, so our 13 becomes 1 here only. So graph cuts here. Or if you can take 300 also. Take 300 also, 3, your graph cuts here only. This point, near point. Okay, means the line becomes like that. Exactly. This becomes line. Just depends on the value. Take 300, 400, whatever it may be. Okay, nearest point in exam hall. Bigger values, bigger scale. Smaller values, smaller scale. Okay. This is the graphical representation. Just find this mark only. In graphical representation, just something is the exact answer, not the exact answer. But graphically, it's not possible to get the exact answer. But show the where the line approximately gets. That's the thing here. Okay. Okay, sir. Let's see. Next, see the behavior of the ABC constants. So we saw the algebraic methods of expression and graphical method of expression representation. Let's see here in this graph only. I am telling you, in this graph only, line may be intersecting, right? Okay, express now. Line may be line may be like that. These are parallel lines, na? So okay, right, maybe something else. Parallel lines. Okay, parallel lines, right? these two are parallel, and these two are coinciding, right? And here and dot. Okay, this is the line, this is the other one line, this is the other one line. See, this is the point of coincidence. Okay, this I am writing as y1, y2, y3, y4. And this is from this one, y5, this is y6. Okay, very important. You can take also this also, y6, y7, y8. Let's take, right? Just simply I will telling you. Okay. There are 8 lines I drawn here. Okay, up from here, this is y. This is from here, from here, from here this is y1. From here this is y2. From this is y5. This is y6. This is y4. This is y3, and this is y8. This is y7. Right? Okay. Just tell me. y1 and y2 are parallel lines because now they have keeping the common distance, constant distance between them. y1 and y2 are parallel lines. Parallel, right? Means they never met. They never met. Parallel lines never met. They were never coincidence, right? y1 and y2. Similarly. y7, okay, y7 and y8, y6 and y5, and each one y4 and y3. All are parallel lines, right? Parallel lines. Then now consider y1 and y5. y1 and not y5, y1 and y8, and y2 and y3. Okay, not only one, you can take also y1 also y8, y1 also y7, y1 and y3, y1 y4. Okay, y1, y8, y7, y3, y4. These lines, okay, we should be writing as y1 and writing as y1 and these lines are coinciding lines, coincident lines. Very careful, because now big point, they exactly one point they cuts. Yes, they cuts. Okay, this line cuts here and this line cuts here. This line cuts here and this line cuts here. Similarly for the y2 also, y2, y3, y2, y4, y2, y7, y2, y8 are called coincident lines. Exactly one point they are getting met. Okay, they met only at one point. Coincident means meeting at one point. y1 and y3, y4, y7, y8, because of cross lines. y1 and y2 are parallel lines. That's it. Coincident lines. Now consider the y8 and y3. y8 this one and y3 this one, and y7 and okay and y4 and y1 and y6 and y2 and y5. Okay, right? It's not coincident lines, they are parallel lines. Intersecting lines, okay sir, which misconception. This is not coincident, this is the intersecting lines. Intersecting lines. Very important. The lines like that, na. This is the point of intersection, like that. So y1, y2. Okay, these are lines cars, na. y1, y3, y1, y8, y7, y3, y4. These are called intersecting lines. Okay, I completely extremely apology for the misinformation. The lines cuts each other. If the two lines cuts each other at a single point, it's called intersecting lines. Intersecting lines, exactly only one solutions, right? Then these lines are called coincident line, continuing lines, coincident lines, coincident lines, coincident, very important, like that. One line, another line. This is y1, this is y2, this is -5, not that maybe. Okay, coinciding. Okay, the one line is overlapping on another line. One line is coinciding the another line, or one line is overlapping on the another line. This is called coincident line. Here y1, y6, y2, y5, y8, y3, y7, y4. Okay. Let's see the examples as well. Parallel lines means they have the common distance between them. They never intersect. Never intersect. Intersecting lines have the only one solutions. They meet only at one point. Means that point of meeting is called intersecting point. Another type of is called coincident lines. Coincident line means overlapping. One lines overlap the other lines. Okay. This is the graphical method, graphical solution we saw it, but by the values of ABC with respect to A1, B1, C1. So then you can decide also the lines whether intersecting lines, whether lines are parallel lines, whether lines are the coinciding lines. Okay, let's see that also. Examples. Okay students, next concept is wonderful concept. Only one thing you can decide here only, the behavior of the x and y. Okay, by seeing the ABCD. So okay, you know what the value is. General equation is a1 x1. Okay, general form is a1 x1 plus b1 y1 plus c1 is equal to 0 and a2 x2 plus b2 y2 plus c2 is equal to 0. Right? General solutions. Here I think a1 a2 ratio, b1 b2 ratio, c1 c2 ratio, conditions and comparisons. What the graph, what is the algebraic solution also you can tell. Okay, just check here a1 by a2, so 1 by 3 and here minus 2 by 4 is equal to minus 1 by 2 and here is x minus 2y only, no? Yes, 0. Something is 0 by 20. 0 by minus 20 is equal to 0. Okay. So what the here is, I can tell a1 by a2 is not equal to b1 by b2 not equal to c1 by c2. Let's compare them, sir. a1 by a2 is equal to 1 by 3, b1 by b2 is equal to minus 1 by 2, c1 by c2 is equal to 0 by minus 20. So here clearly a1 by a2 not equal to b1 by b2 not equal to c1 by c2 not equal to. Then exactly these are called intersecting lines. Intersecting lines, pair of lines we are called. So here exactly one solution. Exactly one solution. Okay. Then I will tell you what the consistent or not consistent. Okay. What the consistent and or the inconsistent lines also. Right. Second with respect to. So this is a1 by 2 by 4 is equal to 1 by 2. Here 3 by 6 is equal to 1 by 2. Right. Here minus 9 by minus 18 is equal to 1 by 2. Right. Here what we have, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Right. See the a1 by b is equal to 1 by 2, b1 by b is equal to 1 by 2, c1 is equal to 1 by 1 by 2. This is graph is coincident lines. Okay, this is like that. I am simply telling this graph is like that. Lines are okay. Lines are like that. Okay, this is coincident lines. Coincident lines. Okay, the graph is like that. Okay, this is y1, this is y2. Here na, this is y1 and this is y2. Coincidence, or you can tell also just overlapping also. Here also you can write. Right. The last one is, let's check the a1 by 2 is 1 by 2. Right. b1 by 2 is 2 by 4 is equal to 1 by 2 and this is minus 4 by minus 12 is equal to 1 by 3. For the condition here, a1 by a2 is not equal, okay, is equal to a by is equal to b1 by b2 but not equal to c1 by c2. Okay, this is called parallel lines. Parallel like that. From here y1, from here y2. These are the lines are parallel. These are the coincidence. Okay, the infinitely many solutions. Infinitely many solutions means that every point is coinciding. Every point is coinciding. So all solutions, all points are nothing but a solutions. Okay, this is no solutions. No solutions. There is no solution for this equation. Thus, only single graph you can represent anything else. If the coefficients of the two linear equations, not the ratio of the coefficients of corresponding coefficients not equal, the ratio of the coefficients corresponding coefficients of the equations, linear equations are not equal, then the lines are completely perfectly intersecting and have exactly only one solution. Means one point of contact. There is a one common point where both lines meets each other. Second one is the ratio of the corresponding coefficients of the lines are equal. The ratios are equal. Then every point itself on the is a solution. Every point on the line itself is a solution. Okay, that is means every point means they are independently many solutions. Every point itself is solution. That is called, so both these are called dependent. Okay, both these are called consistent or called dependent. Consistent or dependent. Okay, because consistently they have one solution, at least one solution. It consists many solutions, it consists one solution. It depends on one solution, depends on the many solution. These are called no solution means parallel lines are called inconsistent solution, inconsistent lines, independent lines. Independence because called dependent lines, independence are called, that is dependent, that is the consistent, this is inconsistent. Right? Once I am repeating here. If the ratios of the coefficients of variables, corresponding variables are equal, the ratios of corresponding variables, ratio of the coefficient of the corresponding variables are same, not equal, the line is perfectly intersecting, have only one solution. It's same if the ratios of the corresponding coefficients of two equations are equal, then lines are coinciding, means overlapping. One line is overlapping in another line, so it has infinitely many solutions. Means it's also inconsistent, consistent solution. If the lines, if the two at the way the coefficients of the ratio of the coefficients of x and y only equal, then third constant ratio is not equal, then the lines are perfectly parallel. Means does not have any solution. Lines does not have any solutions. This is called inconsistent or independent relationship, you can call. Okay. Next concept is only to represent this some equation with graphical method. Exercise is there. Okay. Just see the check the whether see okay depends on the only check ratio of this one. If it not equal, intersecting one point. If the all threes are equal, main find main solutions. If the A and B, A1, B1 is equal to B1, C2 but not equal to C1, C2, parallel lines. This is only questions. Cool. You already know graphical representation and algebraic method. The word problem, how to write the algebraic method. We take an example. And next is simple only. Take the ratios and by this chart you can judge whether lines are intersecting, non-intersecting. Okay. One simple, just see this one, remember this one. This one. If the lines are not equal, then automatically intersecting lines. If the C1, C2 is not equal, then parallel. Remaining is, this is okay. Infinitely many solutions, okay. Okay. Either you have to buy it or remember, but just solving the many examples, you came to know what is the meaning of this one. Okay. We have the solutions called consistent solution, consistent equations. If it does not have solution, it's called inconsistent or independent, dependent and independent. Okay. So here I am going to conclude the class. I hope this is the basic introduction. Okay. Comparatively for ICSE and NCERT give the basic concepts, because now I don't know whether questions are easy, but students gets confused over the things, how to represent, how to think these things. Only mathematics, repetition itself is the king of learning. Unlike other subjects, civics or geography, something else, mathematics needs discipline and practice. Until and unless you are not practicing the questions every day on this same difficult chapters, you'll never get the things done. Okay. However, it may be easy. I have the teachers telling an easiest way. I may be making hard work, but you, the students, should work on hard. Okay. Have to rigorously figure out the questions, different questions. Why it is, how it is, why it is, how it is. Then, to some extent, some threshold endeavor, threshold tiredness. Okay. that limit that till you came to know, yes, I understand this basic something else, then you are unstoppable. Okay, let's do the questions. So my MO is first I will complete the syllabus completely, what it may be for board exams. Then I will take the test or caution, either as part or test or something else randomly, so that can be helpful to the students also. So first I will complete the syllabus set, or it may be taking the 1 or 2 examples by sub concept, each concept. Okay, that's all. Again, give me the feedback, whatever may be mistakes. Now please correct my errors, correct my mistakes by giving your valuable feedback on the comment box. Okay, thanks for thank you again watching this class. Bye.